The locus of complex number z satisfying the argument of z minus z0 is theta is a ray or half-line emanating from the point z0 in the complex plane, but not including z0 and making angle theta with this dashed line parallel to the real axis. The reason we're not including z0 is that the argument of 0 is not defined. So we can't say the argument of wouldn't make sense to say the argument of 0 is theta if we include z0. So it's just all of the points on this half line. So it's a half line because it doesn't include the line extended in the other direction, just extending in this direction, and it's all of the points on this line. So let's find the Cartesian equation of the line, the half line. If we let z be x plus iy and z0 be this, then the point z could lie anywhere on this line. Wherever it lies, if we drop a perpendicular, we can make a right-angled triangle. And all of these right-angled triangles we can make are similar. The angle theta here is the same in each triangle. So given this triangle, we know if we take one of these points and we call it z, so this is z0, so this distance is the difference between the x coordinates, which is x, x0 plus iy0 is x minus x0, and the difference in heights is y minus y0. And then, so tan theta is y minus y0 over x minus x0. And we can rearrange this if we multiply by x minus x0 and then rearrange, we get that y is y minus y0 plus x minus x0 lots of tan theta. So this half line has gradient tan theta, and this is its Cartesian equation. So now if we move on to this example, given the argument of z plus 3 plus 2i is 3 pi by 4, sketch the locus of z and find the Cartesian equation. Well, so the locus is a ray beginning at the point minus 3 minus 2i, which is down here, that makes angle 3 pi by 4 with this dashed line parallel to the real axis. So the locus looks like this, where this angle here is 3 pi by 4, and this is minus 3 minus 2i. And then to find the Cartesian equation, we can just use what we did here. So tan of 3 pi by 4 is y minus y0, that's 2, over x minus x0, that's minus 3, and tan of 3 pi by 4 is minus 1. So we get y plus 2 is minus x minus 3, so therefore y is minus x minus 5. And then to find a complex number z satisfying this, and also that the modulus of z plus 3 plus 2i is 10, we also have that it lies on the circle centered at this point of radius 10. So if we were to draw a circle around this point of radius 10, we have one point of intersection over here. So there are a couple of ways we could do this. One is to use this Cartesian equation, find the Cartesian of the equation of the circle and solve simultaneously. A more clever way would be to observe we need this distance to be 10, and if we extend this dashed line backwards, we have a right-angled triangle here where we know the hypotenuse and we know this angle here. This angle is pi by 4. So we have this triangle where this is 10 and this is pi by 4, and hence we can find the other two sides in this triangle. So the other side is going to be, this is 10 sine pi by 4, which is 5 root 2, and this is 10 cos pi by 4, which is also 5 root 2. And then we can just, so we know, so therefore z, well, the x coordinate of this is -3, and then minus another 5 root 2, and then the y coordinate is -2, and then add 5 root 2. 5 root 2 minus 2i. And that's the answer.